That's crazy. The MEMS speakers is actually insane. So I was really curious about MEMS speakers lately, but unfortunately my QCY N70 might not be lost on delivery. So instead, today we are talking about this Soundpeat Air 5 Pro Plus, which come with the first mass-produced XM speakers, paired with a 10mm dynamic driver. If you ask me, I think the MEMS speaker is going to completely change the game. Here's why. First thing first, let's find out what is the MEMS. MEMS, or Micro Electromechanical System, isn't really a new technology actually. In fact, most of the microphones in our phones and earphones today are actually using MEMS mics. Just like that. In simple terms, MEMS speakers use a similar structure to the MEMS mics. But MEMS mics are sensors which receive signal. Meanwhile, the MEMS speakers are the actuators which convert the signal. The advantages of the MEMS speakers are clear. First, they can be directly integrated into the PCB board, saving a huge amount of space in the TWS. For example, a typical 10mm dynamic driver has a volume of around 250 to 400 cubic millimeters, but the MEMS speaker's packaging size is just about 48 to 150 cubic millimeters. I mean, that's a massive reduction in the size of the earphone cavity. Another key advantage is that the MEMS has extremely high sensitivity and very low harmonic distortion. Typically, a dynamic driver normally have THD around 1 to 2%, but a MEMS speaker can achieve THD as low as the 0.2 to 0.5%. I mean, this is already in the same ballpark as electrostatic and planar magnetic drivers. And as we all know, electrostatic and planar magnetic drivers are super expensive and have high power consumptions. And still, MEMS speakers are smaller. However, there are still some challenges. Like the planar driver or the balance armature, MEMS speakers currently struggle with low frequency response as well. Well, there are already half the full range MEMS solutions, but we haven't yet seen a product that uses a MEMS as a solo driver. That's where the Soundpeat Air 5 Pro Plus come in, feature a hybrid solution with a 10mm dynamic driver as a main unit and a MEMS serving as a tweeter to handle the highs, just like the BA/DD solutions. So what does the MEMS bring to the table compared to the traditional DD plus BA setup? As you can hear in the demo earlier, MEMS has an incredible transient response, better than both dynamic and balance armature drivers. It also keeps the distortion much lower. Unlike the BA drivers, which can have inherent resonance peaks, MEMS driver delivers cleaner, more precise highs. It's like getting a purity and accuracy of the BA, but with the natural sound and soundstage you would expect from the dynamic driver. Take a look at the frequency response of the Soundpeat Air 5 Pro Plus compared to the Soundpeats H3 and Oneplus4. You can see that H3 has that classic BA resonance peak between the 2 kHz and the 6 kHz, making the vocals sound a bit thick and coloration is quite heavy. The Oneplus4, while good for dynamic driver, doesn't quite have the smoothness and natural extension that the Air 5 Pro Plus has. Now, let's talk about some of the drawbacks of the MEMS. First, the cost is still relatively high. This is quite similar to the noise drivers because this is actually the patent technology. Right now, only companies like the USound and XMEMS have visible solutions. Since I haven't received my QCY N70s yet, I can't fully compare the differences between these two manufacturers. Another issue is that the MEMS driver still requires a separate amplifier, which increasing the power consumption of the earphones. This ultimately impacts battery life, and if the MEMS were to be used as a main driver, the lack of the low end will still be a challenge for the foreseeable future. That being said, I think the MEMS technology is evolving rapidly. As of the past months, we've already seen the solution that don't even need an amplifier. I believe that with more companies entering the market and costs coming down, the MEMS speakers will soon be the go-to option for the high-resolution audio.